In this video, I'm going to show you our first method for solving quadratics that have three terms. In example 0, we saw how to solve quadratics of the form ax squared plus bx equals 0, where the constant term or the last term is missing. So that's like if 12 wasn't there and 6 wasn't there here and yada yada. Okay, and we also saw how to solve quadratics that are of the form ax squared plus c equals 0, where they're missing the middle term. Yeah, okay. And so that was in method 0. This time we're going to learn how to deal with quadratics that are like these 4 up here. And what these 4 have in common is that a is 1. The leading coefficient is 1 right there. It's 1 right there. It's not written because it's 1, but yeah, it's 1 in all 4 cases. And that needs to be the case in order for you to use this method I'm going to teach you, which I call the factoring method. Yeah, and at the end of the video, I'm going to show you why this method works. For now, I'm just going to go through the examples. So let's start with the very first one. So on the very first one, what we're doing is we say we've got x squared plus 7x plus 12 equals 0, and what you need to do is take the constant term, so the last term, 12, and figure out all the pair of numbers that multiply to 12. So I start with 1 and 12, that's easy, and I also know negative 1 and negative 12 will have to work, so I always write the negative versions, and then 2 and 6, and then it's negative 2 and negative 6, and then 3 and 4, and then negative 3 and negative 4. And of all these pairs of numbers, I choose the ones that add to the middle term. And so that's 3 and 4, right? Negative 3 and negative 4 are close, but it's 3 and 4 because this is positive 7. So what that means is our two factors, our two binomials are going to be x plus 3 and x plus 4, that when multiplied will give us this. So we're basically taking the trinomial and rewriting it as the product of two binomials, because now it will be easy to see how to make this 0. So what x's make it 0 is not so clear there, but it is clear here. Since I have something times something equals 0, I only require that either this is 0 or this is 0. Well, this is 0 if x is negative 3. So I've got x equals negative 3. Or, and this is 0 when x is negative 4. So x equals negative 4. So this is pretty cool, and it's a reliable method. But it doesn't always work. We could look at like x squared plus 5x plus 3 equals 0. And notice that there are no pair of numbers that multiply to 3 and at the same time add to 5. So it doesn't always work, and therefore you might have to use the Babylonian method or the quadratic formula or completing the square, which always work. But this is one of the first methods you should try to use. Unless you see after trying it that it doesn't work, you should always try and see if you can use this method. It's a fairly straightforward method, and it works on a lot of quadratics. Yeah? Okay, cool. Now, we just did this, so let's go to this one. And whereas for this guy, both of the numbers we chose were positive, what we're going to find is here, both of the numbers we choose are going to be negative. But yeah, let's make room and get started. Now, so this guy here, I write as x squared minus 5x plus 6 is equal to 0. And so I figure out all the numbers that multiply to 6, all the pair of numbers that multiply to 6. So that is 1 and 6, and so negative 1 and negative 6, and then 2 and 3, and then negative 2 and negative 3, and that's it. And of all of these, I choose the pair that adds to negative 5, and that's these two. So we're going to have x minus 2 times x minus 3 equals 0. And so x equals 2 or x equals 3. So those are our two answers, x equals 2 or x equals 3. And that's that. And let's move on to the next one. So in the next one, we're going to see that one of the numbers is going to be positive and the other is going to be negative, because we've got -6, and the numbers that multiply to -6, the pairs, are 1 and -6, and then -1 and 6, and then 2 and -3, and then -2 and 3, and that's it. And of all of these, we need the pair that add to -1. I didn't write a 1 in front of the x, but I can if I wanted, right? So that negative sign by itself in front of x means -1 times x, yeah? Okay, so we need the pair that adds to -1, and that's these two, right? And so we see that x squared minus 1x, or just minus x, minus 6 equals 0 factors as x plus 2 times x minus 3 equals 0. And that would mean you've got x equals -2 or x equals 3. Yeah, cool. All right. Like I said, one of them was going to have to be negative this time, and there it is. Okay, the last example, you have another option for doing the last one, but the fact that this number is the same as this doesn't mean you can't use this. You could still use it. So x squared, the factoring method, that is, x squared plus 4x plus 4 equals 0. So take 4, constant term, figure out all the numbers. It's positive 4. Figure out all the numbers that multiply to it, and that's 1 and 4, -1 and -4, 2 and 2, and then -2 and -2, and pick the pair that adds to this middle term. That's clearly 2 and 2. So we go x plus 2 times x plus 2 is equal to 0. And this time we only have one answer. It's a repeated root. X equals -2. Yeah? Okay, cool. There we are. Now, I did say that you could have done this through a different method, and that's by observing that, what you're given, x squared plus 4x plus 4, quadratic, is in the form x squared plus 2 times 2x, and then plus 2 squared. And since we know that a plus b all squared is a squared plus 2ab plus b squared, we see that b is 2 and a is x, and everything checks out. So this is clearly a plus b all squared, which is x plus 2 all squared. So you could have realized that from the get-go, and immediately realized that the answer has to be x equals -2. If you knew to do that, great. If not, that's okay. This guy here at the bottom that I'm about to erase, I'll circle it. I can't. This guy right here is called the Binomial Square, and I'll have a video dedicated to that. Shoot, I accidentally got rid of what I was gonna, or my lasso. Okay, there it is. Okay, so last but not least, we're going to see why this method works, this factoring method. Why does it work? Why is it that when I take the two numbers that multiply to this and add to this, I'm able to factor it as something plus something times something plus another thing? In other words, I'm able to factor it as a product of two binomials. Of course, like when I write x plus a here, a could be a negative number, right? So I could really mean like x minus 2, right? You get it. So why does this method work is the question. Well, before I answer that, let me give you two extra notes. One is sometimes even when it appears that you cannot use the factoring method, you can. Like I could easily modify this equation by multiplying both sides by x and give you something that looks pretty hard but is actually very easy, which is this. So if I gave you this equation, notice that immediately you can try to factor an x from all three and you'll succeed. And so you take out an x and you get x squared plus 5x plus 6 is equal to 0. Now what's inside of the parenthesis, right? What's inside of here is what we'd already done, which, well, actually I miswrote. That's a minus. Yeah, so clearly inside of the parentheses we'd already done, which is x minus 2. Ooh, sorry, I don't know where I was going with that. I'm rushing now. My writing is getting sloppy. My bad, guys. X minus 2 times x minus 3 equals 0, right? So now from here we get x equals 0, from here x equals 2, and from here x equals 3. So it appeared that this was hard, but actually, like, it's just something simple once you take out a greatest common factor, which was that x we took out in the beginning. And sometimes it's not an x that's multiplying your entire equation. Remember, we said that you can use this method only when the leading coefficient is 1, but sometimes you can use it even when the leading coefficient isn't 1. I'll show you how by modifying this equation. Suppose you're given this, 2x squared plus 14x plus 24 equals 0. Well, it appears that you cannot use this method because the leading coefficient is not 1. In this case, it's 2. But look to see if you can factor out a 2 from all three terms, and you can. So when you do, you're left with a quadratic that you know how to deal with. That was our very first example, right? Equals 0. And so now you've got 2 times x plus 3 times x plus 4 equals 0. So 2 cannot equal 0. And this will equal 0 and x is negative 3. And this will equal 0 and x is negative 4. So actually what we're saying is that this equation and this equation have the same zeros or the same x-intercepts or the same roots, and all three terms just mean x values that make the whole thing true, which is x values that make this quadratic 0, right? So yeah, so what I circled, this guy and this guy, even though we multiplied it by 2, we multiplied this by 2 to get this, right? Even though that's the case, they have the same zeros, namely x equals negative 3 and x equals negative 4. Okay, cool. All right, enough said. Now I'm going to show you why this method works. And this is pretty cool. So we're going to kind of construct it backwards, which is we're going to assume that we have got our linear factor. So we're going to assume that we succeeded in writing x plus a. And again, like I said, a could be a negative number. So this could mean x plus a negative 2, therefore x minus 2. But yeah, we're going to assume that we've factored it, and we've got x plus a times x plus b in factored form. Every time we've been able to factor it, that's where we get to, right? Two binomials multiplied. Okay, cool. Well, let's see the trinomial that this would make once we multiply the two binomials. That is FOIL. So the f in FOIL would say x squared, and then the o would say x times b, so that's plus bx, short for Bronx, on like a random note, and then a times x is going to make ax, right? And that's the inner, the I in FOIL, so ax, and then finally plus a times b. Got it. And now we can factor in the middle, two terms, we can factor out an x. And doing that, we can write the following, which is x squared, and then it's plus, and then I could write b plus a, right? It's a lot of color coding. This is why I don't like color coding. It takes a lot of effort, and I don't know if it's always worth it. And then it's not effort from me alone, effort from you to like be patient stuff. A times b, right? Okay, cool. All right, so wait, isn't that what we said? Like if we had like x squared plus 7x plus 12 via our first example, we said what we should do is try to figure out what two numbers that multiply to this add to that. So the two numbers AB that multiply to that have to add to the middle coefficient. That's exactly what we said. So this is why this method works, yeah? Cool. All right. I hope you appreciated this, and check out the other videos. There are more powerful methods to come. Take care.